Welcome to the Bartlett International Lecture Series. I'm Marie Glynn. I'm the lecturer in interactive architecture, and I suppose it's under that banner that I'm introducing Usman today. I've known Usman for about 10 years, and I think I first met him in his flats in Finsbury Park when I came to do a bit of work experience when I was a student in the park myself. And I have very fond memories of that time. I think it's kind of extraordinary, this small flat that we had was both a home and also this factory for building enormous public artworks. That's still quite understand how we build these things in that small space. And I think my favourite memory was climbing out onto the roof above Usman's flat. There are local flats here at the top flat. And onto this flat roof, getting a load of helium balloons, putting them in a big bag essentially, tying a rope to it, flying it in the air, and us holding onto this rope for dear life, perching over the side of this block of flats. While his mum watched us, she was in charge of health and safety at the time, wearing her high-vis jacket. And it's kind of amazing to see how his work has developed over the last 10 years. I think now for him to really become, I think, one of the leaders really in a field that sort of jumps across all sorts of disciplines. Very much grounded, I think, in his architectural experience. It gives me a great pleasure to introduce him, but I'm almost somewhat embarrassed because I think the honour perhaps should go to Stephen Gage, who taught Usman 20 years ago now or so, as a student being 14. And I think Stephen, we were once talking about Usman, actually said that Usman might be one of those students where he may have learned more from Usman than Usman might have learned from him. But I think maybe perhaps some of that is Stephen's kind of humble manner. I think Usman has, though, undoubtedly had a great influence on the evolution of Unit 14. He taught with Stephen and Phil Ayres for a number of years, up until about 2005. And within the architectural and world of art and design, he went on to receive many, many awards and exhibit his work around the world in great institutions and galleries. He's also gone on to win an equal number of awards and acclaim from the technology industry and innovative systems that he's built. What I think is really interesting about Usman is that in some way it was in the very physical making of his installations early on and observing the way that people interacted with him that I think an understanding came out of that about a real interest in not just one-to-one interactions but many-to-many interactions. What I mean by that is that perhaps like a one-to-one interaction might be, say, an app on my mobile phone that changes the mood lighting of my home if I'm entertaining some guests. And many-to-many would be much more about a kind of primordial soup of things talking to other things, exchanging information, and systems kind of emerging out of kind of interactions, some small, some large, some meaningful, some accidental. And the kind of chaotic, productive quality of those conversations that would occur, rather than perhaps the kind of much more homogeneous and control systems that you might start to see from companies like IBM, Cisco, Apple, and so on. Now, Usman has recently founded Umbrella, which I know absolutely nothing about, so I'm very much looking forward to hearing about that. It follows on from his practice, hack design and research. One of our students from RC3, our cluster, named Tam, started working for Usman, but I haven't had a chance to speak to my spy just yet, so I'm looking forward to hearing all about what you're planning to do next. But I will just finish by saying that I think Usman's interesting as a person on another level. I think he talks about not the Internet of Things, which I'm sure you're all familiar with as a term. He talks more about an ecosystem of environments. And his view on environments is that they are constructs of the observer. And I think that we see in that really the influence of his architectural training and the cybernetic thoughts that ran through Unit 14, the influence of people like Ranulph Glanville or Pascal and so on. And I think he now offers the discipline of architecture a new way to become involved and bring its expertise and knowledge to an emerging set of technologies that will undoubtedly radically change our experience of the built environment. So I'd like you to all join me in welcoming Usman Haque.
Thank you, Rory. Have I got this on correctly now? Yeah. Thank you so much for that lovely introduction. And I should correct you on one thing, which is that if I don't think I in any sense taught Stephen more than he taught me, because I owe pretty much all my thinking and sort of the influence on pretty much all my work to Stephen. So thank you very much. I think the only thing I taught you was that there was such a thing as chipmunk basic, which nobody cares about today anyway. So thank you, and thank you for that really kind introduction. I want to talk to you today about messy cities, and in a sense my contribution to messy cities. But really, there's three things or three questions I'd like to kind of provoke in your minds. One is, how do we value cities? What is the metric through which we ascribe value to cities? Because there are those who would say that it's property prices or investment or what have you. But I think it's something much more human. And the punchline, which you'll get from this talk, is that I think it's about empowerment and engagement and diversity and creativity. And how do we increase that value? If we're going to talk about designing and having cities, how do we actually make them more valuable to us? How do we define the value and how do we increase it? The second thing I'd like to sort of provoke in your minds is this question of what is the role of technology in creating these things of value? Because we know that technology is both it's not neutral. It has social and political aspects to it. But technology is both determined by these socio-political factors as well as being part of determining those socio-political factors. So if you're going to think about valuable cities, what is the role of technology in creating these valuable cities? And then finally, especially because we're in the sort of context of a school of architecture, what is the role of designers and architects in deciding what we do in kind of creating this technology? Because I think we're in an age now where we can almost build anything that we can imagine. That doesn't mean necessarily we should just build anything and everything. So knowing as we do now that there's this continuous spectrum between the architect of old, who kind of was prescriptive in every single thing that anyone might do in his or her building, and on the other end of the equation, the architect that's really a software architect. What is that sort of area in between that actually, where somebody is actually developing a framework with the knowledge that other people are going to live in it, take it on, and turn it into something completely unexpected? So those are the three kind of things that I'd like to kind of provoke in your mind. I don't necessarily have a wonderful answer to all those, but I do think I have some clues that I've sort of picked up along the way, and I hope I'll be sort of giving suggestions about them as we go along. So first, the question of what is a city? There are, of course, thousands of definitions for this, and I don't necessarily want to offer 1,001th or 1,001st. I don't know how you say that. But my intuition is that what actually makes a city is not the buildings and roads and the kind of physical sort of fabric of the city so much as that sort of desire to be all in one place, because we're all here near to each other, in a way that we're not in a non-urban context, in a way that we're not in a sort of rural context. So I think that the idea of a city comes down to some notion of the accretion of these interactions between us, the sort of layering of both familiarity and novelty over time. For me, that's where the kind of first clues of what a city actually is become important. So a city then becomes, in a sense, a kind of an engine for creating serendipity across these interactions. Because in a city, you're much more likely to be confronted by somebody that you disagree with, or to be introduced to an idea that, a novel idea. And I think that this starts to suggest to me ways that cities should be valued in terms of the capacity in a way that almost no other human institution is capable of. A way of actually engineering heterogeneity, a way of sustainably creating a whole bunch of things that contradict each other. Because I think that in cities, you don't find a sort of collapsing of logic where suddenly everything makes sense and everything is seamless, right? The city actually becomes most interesting, most creative, and I would argue most sustainable when you do actually find that you're confronted by complexity and challenge and novelty, and you're introduced to new ideas, and essentially the city becomes a kind of a focus point of creativity. So I want to suggest that if we're going to talk about value in cities, we should be talking about the extent to which a city can continue to engineer or to create or to foster creativity. With that in mind, I want to just introduce this concept of a mess. So Russell Ackoff talks about this idea of a system in which every problem interacts with other problems and is therefore part of a set of interrelated problems, a system of problems. I choose to call such system a mess. And I find this really interesting because what he's saying, this is not a value judgment about sort of messiness or dirtiness. It's about saying that actually there are some systems that don't collapse into a kind of logical coherence where there's an easily and finitely defined boundary. There are systems that are so complex that they really are a mess, where in some cases you can't even figure out where the boundaries of them, where their boundaries are. And you might have come across the term wicked problems. Cities are kind of a perfect example of the wicked problem. A wicked problem, again, not with any value judgment applied to the idea of wicked. We're not talking about evil here. We're talking in wicked problems. These are problems in which, for example, or even better, super wicked problems. Check that out on Wikipedia. These are problems in which, for example, the people who are working to solve the problems are also the ones that are generating the issues that are causing the problems. Wicked problems are those in which you can't even figure out what the causal mechanism is that's giving rise to the thing you're defining as a problem. And so all of these kinds of concept, I think, go into a sort of an idea that we call the city. And it's important to understand, therefore, that mess is not something to be ironed out, right? In the work I'm going to be showing, I'm not trying to simplify stuff, which I think is sometimes proposed as the role of the designer. You know, oh, you're supposed to simplify stuff so that mere mortals can understand it. I'm not trying to sort of give structure to this chaos. I'm not trying to make order out of that chaos. I'm not trying to kind of iron out the wrinkles or paper over the cracks. Actually, if anything, I'm sort of finding those seams and kind of sticking my fingers in them and trying to create seamfulness rather than seamlessness. And this actually resonates, as it turns out. It was kind of unexpected, but it resonates with something that Mark Weiser said. He's kind of looked at as the grandfather of so-called ubiquitous computing. In one of his first papers, now almost about 20 years ago, envisaging an age when computers are embedded in everything, he talked about not aiming towards seamlessness of technology, but seamfulness. The idea that we don't want to sort of make technology disappear so that we don't know it's there and we don't know how it's acting upon us, but that actually we want it to sort of expose our environment to us so that we're more aware of what's going on and the sort of structural relations inherent within it. So why am I concentrating on this idea of the mess? Well, because in this day and age, as Rory alluded to in the introduction, companies like Cisco and IBM are becoming the urbanists for the next 10 or 20 years, right? They're the ones who are proposing and supposedly starting to deliver on smart cities. And if you look at the way the idea of the smart city is kind of packaged, what they're trying to sell you is this idea of convenience and predictability and efficiency and security and optimization, right? Because that's actually what they've always done as technology companies. And they're trying to figure out, you know, between you and me and about 100 million other people, they're trying to figure out how to make their businesses sustainable in this kind of new, more complex world. So they'll describe systems that will help you get to work on time. You know, look at the marketing material. This is exactly how they sell it. You'll get to work on time. You'll be able to shop seamlessly. There'll be sort of security cameras that are monitoring your every move to help you feel more safe. There'll be sort of technology embedded in the roads to help you cross more safely. Basically, all these things that are kind of saying to you, you know what, you're a little bit stupid, humans. We're going to make sure you can cross that road a little bit more safely. They're not talking about trying to figure out ways to improve transportation so that you don't need to worry about cars running you over. They're not talking about alternative means of getting around the city that don't rely on four wheels and an engine. They're talking about ways to kind of, you know, just make it paper over all those cracks. And this is problematic for a whole bunch of reasons. First, they see the city as a problem that can be solved. I mean, this is the classic kind of engineering process. They see that there is a problem, and if we apply certain bits of technology, it's going to be solved. And the reason this is scary to me is that this is almost exactly the language that was used in the 50s and 60s to propose the introduction of highways and high-rises, right? You know, we were told that it was going to make, you know, connect up communities, make us more efficient, you know, safer, secure, blah, 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 right? And we know the disaster that highways carved through New York City have had, you know, destroying communities, but also resulting in just the absolutely horrible air quality effects that have resulted in pretty drastic increase in asthma. We've seen now that high rises actually result in these sort of, in many cases, kind of undesirable social consequences. And so I'm essentially arguing that we've seen the problem with trying to create efficient cities, and it hasn't worked out. And in any case, we don't want efficient cities, right? That is not the metric by which we value cities. They make, you know, getting to work on time or catching your train from your bus with the minimum amount of weight, that makes the city bearable. But that kind of phenomenon has been in place in East Asia for, you know, a few decades now. It wasn't a technological problem. It wasn't something that was solved by technology. This is a sort of socio-political phenomenon. And so these systems that the kind of IBMs and Ciscos and Siemens and Living Planets of the world are proposing are really geared towards the city managers, right? Not the citizens. It's towards the city managers who want to have this kind of, who have this God fantasy of control over the city, whereby by having access to data from everything that's going on, they're somehow going to be able to make the perfect decision. And, you know, if you follow this backwards, this is a completely different lecture to get into, but if you follow this backwards, this is a sort of continuation of the Age of Enlightenment, this idea that simply by having knowledge, we're going to have the sort of perfect decisions. The consequence of it, though, is that it enables those city managers and the people who are kind of using the data to orchestrate the city, enables them to kind of abdicate all responsibility for any of the decisions made. So they can kind of say, well, you know, it wasn't me who decided to close that down, it was the data, or it was the algorithm that set it. So all of this is what I'm trying to sort of rescript, if you like, sort of say there is actually another way possible. There is another way that we can that we can think about and develop our cities. That there is a kind of an alternative approach to actually involve people in the production of those cities, and actually that's really the only thing that makes those cities valuable. So with that in mind, I'm going to run through a few projects here, and I just realized I might have skipped one thing, but I'll come back to that later. So what I'm going to do is I'm going to talk through a selection of the projects over the last 10 years or so to kind of to provide sort of snapshots of ways in part to deal with this condition, but also in part to contribute to the mess. Open Burble was a project that was commissioned by the Singapore Biennale, and it started in my mind with the image of Jack and the Beanstalk and this question of how might I as a citizen create something so large that it operated on the kind of visual scale of the high-rises that surround me in the city. Because I think often as occupants of a city, we do feel like that, like occupants, not kind of contributors. So what would it be to be a member of a city that's actually creating some of the structure in the city? That was the starting point, and via several other projects and things like that, which I'm not going to go into now, I ended up creating this modular system based on basically a kind of carbon fiber structure with balloons and sensors in them, an early prototype of which Rory, you were talking about in the introduction. And the idea here was that it would become a kind of kit of parts where members of the public could come together and basically design, assemble, and then mount a massive structure, sort of 15 stories tall, that they would then also decide the position of and how it responds to them and things like that. So these are some photos from the event. There's some people assembling things on site, starting to inflate them, and some photos from the structure itself. So the idea here is that there's this massive structure which has been designed and assembled by members of the public. They've figured out how to assemble this, put this thing together. The way the colors flow through the structure are determined by how they assembled it. So if you're familiar with cellular automata, the kind of patterns of color moving through the structure are explicitly determined by the orientation and the kind of configuration in the first place. I skipped over a little bit of video there, but I think you get the idea. Here's some photographs from the event itself. We did it in London as well, but unfortunately with less audience participation because there was a certain alcoholic rowdiness to it, which precluded the full participation we were looking for. So that was Open Burble. Primal Source was commissioned by the city of Santa Monica. And in this case, the task was to think about something, how to develop something where there would be potentially 50,000 people. And I wanted to figure out how to actually involve them in constructing that experience themselves. You know, how do you actually feel in the kind of chaos of 1,000 voices that you've actually done something specific? And so I kind of imagined this idea of a kind of a floating cloud, a cloud floating above the beach, in which every single voice, every utterance creates a form, and the important thing being you should be able to recognize your voice within that cloud. And so there was a very tough engineering problem here, which was how to create something that was so immediately recognizable as yours. And so this was actually structured a little bit like a kind of game. There was a row of microphones, and every single one of those creatures is one person's voice. At one point, all the voices are flowing up to the top of this cloud, and then at other moments, all the creatures that were created get sucked out and drawn to whichever part of the crowd was loudest. Now, so what was interesting to me here was to observe, that's not Stephen. What was interesting to me here was to look at, because this kind of thing you can't test, right? I mean, you can test it with one person, but you can't test how 20,000 people are going to respond to something without actually having 20,000 people there. And so what was interesting to me was first to see the diversity of the ways that people responded to it, because there were no instructions. There were absolutely no instructions to the thing as you kind of encountered it. So first, to just see how people were testing it, playing it. You know, you heard some people chanting the alphabet, other people screaming their heads off, some people trying to coordinate and actually do a kind of call and response across the crowd. If you stepped back about 10 people from the front, where there was less connection between the audio and the visual, because they couldn't necessarily hear the person that was making the noise, I actually stood in the crowd and I heard people saying, why don't they just shut up? I want to see this thing, and I want to experience it in silence. Because they didn't realize necessarily that there was this kind of act of creating the experience. So the second thing that was interesting to me was how people started explaining it to each other. You know, and everyone had completely different stories. Again, you know, wandering around the crowds. And this is, I have to say, probably one of the reasons I love doing mass participation spectacles, is because you as a kind of architect or designer, you're a completely anonymous figure, and you can just go and wander out among the crowds and listen to the things that people are saying. And they have no idea who you are, so you have no effect on them. And you can hear people explaining, criticizing, you know, celebrating, sort of developing a whole narrative for what was going on and trying to teach each other what was going on. So this was an important point for me, to start to think about not just the idea that I'm a designer putting something in there where people kind of do something that responds to them, but more importantly, to understand that I was putting something into public that was generating a narrative that I had very little control over once it was out there, that it was generating memories that I didn't necessarily have. I wasn't necessarily going to be prescriptive about how those memories were described, either to people themselves or between people. This led to Marling, which was done last year, where I started to think more carefully about how to turn this into a kind of three-dimensional experience in a public square. And how do you actually generate, let's say, you know, more kind of considered and deliberate vocal participation. And so here, one of the problems with Primal Source was the thing was in front of you and you were sort of behind it. In Marling, I wanted to create something where it was all above you, it was all around you. And your voice, and this system gives you permission to use your voice to generate the space around you. And so again, this is the kind of system where you cannot test it very much until you actually have a whole bunch of people there. And so you'll see that it goes through a whole bunch of different modes because we weren't really sure which ones would work and which ones wouldn't, which ones would provoke certain types of accretive response and how many would sort of have a sort of negative feedback effect. So this, by the way, this was achieved by positioning fog machines around the space and then using lasers that would sort of intersect with that fog to create the 3D shapes that floated above the audience. This was an interesting effect here, where we were able to create these kind of cube-like grids floating in space, and that was because, you know, the fog, as it drifts with the wind, has a kind of a finite form, and so by projecting lasers through it and knowing that they were going to be cut off at a certain point, it actually looks like a cube. So this project for me sort of was a reminder that there's a value in having projects where you just had to be there because the way this is photographed and the way it's even videoed, I think a lot of people don't think it was necessary. You know, it looks photoshopped or it looks kind of a little bit faked. But you know, you had to be there to actually experience this. And so there's this kind of triggered for me the idea of building a shared public memory where doing something in that public space persists for a while, for hopefully a long while afterwards. It sort of reprograms your idea. If you're an inhabitant of that city, it reprograms your idea of what is possible in public space. You know, this project kind of gave permission, as I said earlier, it gave them permission to do stuff they would never do if it wasn't there. Like just stand in the middle of a public square and sing, or to yodel, or to, you know, to scream your head off. You start to think of these kind of these events and installations as things that draw people out to do stuff that they don't feel perhaps they have permission to in other contexts. So now I'm going to talk a little bit about some so-called Internet of Things projects. But I'm going to start that by talking about not just air quality, but qualities of air. And this is by way of sort of describing a workshop I did at IAC in Barcelona a few years ago. In cities around the world, you'll see these kinds of pollution monitoring systems. And usually what happens is they are deployed at sort of even spacing across the city. And they're measuring usually at a height of sort of 3 to 5 to 6 meters off the ground. They're looking for particulates. They're looking for possibly NO2, et cetera, et cetera. They're basically looking to create maps of the air quality across a city. Now, this is all well and good for the people who have deployed this, which is usually a sort of local government or research scientists. But for actual citizens, the data that's generated by these networks is fundamentally unhelpful, I would argue. For a start, as a citizen to experience what is being measured, you'd actually have to be that high off the ground, you know, to be actually breathing the air that these sensors are measuring. Now, scientists would argue that the reason you have these sensors that high off the ground is you don't want to have them low down on the ground where, you know, you have particulate pooling and you have sort of maxima of measurements that are kind of going to throw off the average results for this map that you're building across the city. But I would argue that actually it is those maxima that you're most interested in, right? Those are the bits that you as a citizen are probably going to be concerned about, because that's where you're pushing your child through, or where you are walking through, or what have you. And so this idea that you have a pollution network that's creating a lovely visualization of where air quality is good and where it's bad is, I think, totally bogus, because as citizens, we can't even use those maps. Right? You get a map that shows that you've got bad air quality in your neighborhood. What are you supposed to do? Just, oh, I'm going to move? Right? You know, very few of us have that kind of capital fluidity that we can just sort of say, oh, I'm going to suddenly change where I live, or I'm going to change the way, change where I work, or what have you. Secondly, if you decided to do something about it, to try an experiment in improving your air quality, this data would not reflect it, because your actions, even if you got together with your neighbors to decide to do something, would not move the needle one bit. So I want to argue in this case that actually when it comes to something like air quality, it's much more important to get people involved in thinking about the qualities of air themselves directly. You know, forget about the data. Get them involved in actually making sense of the particulate itself, in making sense of the way that air moves in and around their homes. Get them involved in actually being able to conduct experiments where they can also evaluate the results of those experiments. Because ultimately, that really is the way of getting people engaged in, you know, in this whole notion of data, is to enable people or empower them to make decisions around that data. And so with that in mind, the workshop in Barcelona, which I did with Natalie Jeremijenko, the engineer and artist, first got participants to walk around and take swabs using a white napkin every 1 or 2 meters along streets of Barcelona, and to wipe up the particulate on those horizontal surfaces, which might have been window ledges, or they could have been steps, or they could have been even just the area where bricks stick out, and create very quickly, in the space of an hour, a whole heap of these samples of the amount of actual particulate that had deposited at that location. And then to get all that information together, because the human eye, as a kind of grayscale detector, is incredibly accurate. And so by people actually evaluating in discussion with each other the grayscale measurement of that grayness from each of the locations and then quantifying that and putting it on a map, I would argue it gives them a much better sense of, and more importantly, a kind of a collective understanding of the way the particulate amassed around the built forms that they were measuring than if they'd gone around with an air quality monitor and just sort of typed in some numbers. So what they were able to do was map out this whole sort of neighborhood and to look at where on which intersections the air quality, or rather the particulate deposition increased, et cetera, et cetera. And then actually took this onto the building, put ribbons all over the place to start to understand better the way that air flowed, first on the outside of the building and then later inside the building. And they have a fab lab there, which of course is generating the most toxic output you could possibly have in an architecture school. And everyone was worried about it, but nobody was really sure what kind of technological mechanism could be used to extract this, to best protect the indoor air quality. And by putting up ribbons everywhere, they discovered that by closing certain doors and opening certain windows, they could actually, in a very low-tech way, ensure the continued airflow extraction without needing to have any kind of machinery, not needing any kind of sensor in the traditional digital sense. And so this was a kind of interesting moment for me to think about data not necessarily being something that was simply plucked from the air using a sensor, but data being something that's actually crafted and created in an effort to make sense of and then make decisions about something. With that in mind, I'm going to talk about PatchBay, which is a web system that I launched back in 2007 or 2008. Now, going back about 10 years ago, we had a whole bunch of projects around the world, sometimes temporary installations in galleries or institutions that were these sort of interactive environments. And as one does, you kind of miss, or you kind of, you feel a fondness for the thing you created, and then you have to go home and it's far away. And so my very first desire was to think about, well, how can I carry on watching what's going on in that interactive environment that I just built in Japan? How can I see whether things are working, find out whether the sensors are okay, see whether anyone's visiting the thing, and still feel a kind of sense of connectivity to it. And so I created, at the time it was a really basic thing, which was to take the values from the interactive environment that I'd built, which in many cases were built around the Arduino platform, and push that data to a JavaScript widget that would appear in a website, so that whenever I did an interactive environment, I could immediately see in real time what the values were in the physical space. It was a kind of a weaving, if you like, of the kind of the physical space of the environment with the sort of digital space of the web page. And then I realized that once I had a few of these things connected up to the internet, actually I could start to get them to respond to each other. And so at one point I had an exhibition in Japan and one in Boston, and I started having them respond to each other in real time, so that things that people were doing in Japan were triggering things that were going on in Boston. And then at the same time, for some reason, got commissioned to do a project in Second Life, the virtual environment. And so use the same system to start to trigger stuff in Second Life, and have Second Life in, occupants sort of trigger stuff in the physical world. And so basically started creating this kind of sequence of connected environments using, at that time, a really hacky platform, and found that colleagues and friends and other architects and designers also wanted to join in and be part of this growing network. At the time, it was called Environment XML, which is a really horrible name. Not that PatchBay is so much better, but anyway, so discovered this kind of, this phenomenon was actually seemed to be ticking some people's boxes. And so in 2007, I spun off from my design company a separate company called Connected Environments that was explicitly geared towards basically creating technology to connect up remote environments, to create, as Ruri said, ecosystems of environments. And what we did is in very early 2008 launched Patch Bay. The reason for the spelling is that a patch bay is basically a switchboard where you can plug anything into anything else. And I thought I was going to be launching this mostly in East Asia first, so I had this sort of phonetic idea of patch bay. Anyway, that's actually the story behind the name. And essentially what it was a repository for sensor data in a very general sense. So whether you had a weather station, an energy monitor, a radiation monitor, an air quality monitor, if you had a home automation system, if you had a connected fridge, if you like, you could push the data to the system, but you could also pull other people's data to for your application. And in that sense, it was kind of regarded in the early years as a bit of a sort of a Twitter or YouTube for connected environments and connected sensors. And over the next couple of years, the community grew and grew and grew, tens of thousands of people. And we ended up basically having connections across the world of all sorts of data. And even an energy company called Current Cost built an energy monitor that out of the box would push data to Patch Bay. And then the developer community, which included sort of both the sort of design end of the spectrum, especially a lot of people using Arduino, but at the other end of the spectrum, also people deploying actual products, started creating applications on top of that data, different sort of mobile apps and notification apps and sort of visualization and analytical apps for making sense of that data. It had a kind of a moment of clarity, I suppose. It occurred basically around the disaster at Fukushima, when the Japanese government was not able to get radiation data out to the citizens quickly enough or in the format that was required. They were releasing information about the Fukushima crisis, occasionally in PDF reports that just sort of had a bunch of numbers that made no sense to anybody. They had measurements taken from different prefectures across the country, but they were measured in completely different ways. In one instance, they were measuring radiation at 80 meters off the ground, which really has no bearing whatsoever on the citizens. But more importantly, they weren't really trying to help citizens make sense of any of this data at all. And what we discovered was that the Japanese community, in the space of days, had wired up basically around 2,000 feeds across the country, some of which were pushing data once per second from their connected Geiger counters. And so people had created tutorials for each other on how to take this model of radiation monitor and push the data to the platform. Other people who maybe weren't necessarily building the software were advising on the sort of radiation data. The interesting thing that occurred was that once this data was being generated by a public and monitored by a public, especially in Twitter, was the conversations that would take place around that data, trying to make sense of it. So people would have the natural question, like, what do microsieverts mean? What does it mean that it's this value here and that value there? How do I look at something that's nano-gray and compare that to microsieverts? More importantly, there was also this idea that that by having this as a kind of public process, the people who were experts in radiation would feedback in real time, and we actually saw in the Japanese Twitter feed radiation experts sort of saying to owners of feeds, hey, you know what, you probably got the wrong units there. That's not microsieverts, it's nano-gray. And in another case, advising somebody that clearly you've got your monitor pointed in the wrong direction. You've probably got it pointed down and it should be up. And so by doing this as a kind of public exercise, it became really a kind of a collective sense-making exercise for making sense of what was going on in the radiation environment around the country. But I think it was the next stage that actually became really interesting to me, which was the stuff that was built on that data. So there were visualization tools. There was Winds of Fukushima, which was an app by somebody that took the radiation data and the wind data and basically created a kind of prediction tool for where the radiation would peak next. And then there were things like the, what was it called? The Geiger maps, I think it's called, by Haiyan Zhang, which is basically a map of the health effects of certain levels of radiation across across the country. People had sort of notifications on each other's radiation monitors, so you didn't need to have your own radiation monitor. As long as your neighbor did, you could get an SMS when the value went above a certain amount. If you didn't have a connected radiation monitor, somebody had built a tool for just manually uploading the data. And even to this day, as far as I know, Yahoo Japan continues to use these feeds of data, uncredited, I should say, to actually provide a sort of a radiation report for what's going on in the country. So with Patch Bay, it was a kind of unexpectedly became, if you like, almost like a kind of a global sense-making process for this thing called the Internet of Things, which was not what I'd envisaged in the first place, because I wasn't, I didn't even think about the Internet of Things so much as thinking about, how can we just store and share data and make use of it, and hopefully help other people find something valuable in what you're doing. Because that's kind of been the thing that has engineered value, if you like, in the web as well. It's been this idea that by making stuff available to others, they're going to help you realize why the thing that you're writing or the thing that you're creating actually is beneficial or has value in the world. So that was Patch Bay. It ended up getting bought by a company called LogMeIn and is now called Xively. And I think it's got a much more manufacturer-oriented approach now. But since there are now a bunch of platforms around that are doing this kind of thing, some are more public and some are more private. In other words, now that 5 years on, the world is increasingly connected, and there's more products you can now get that are connected to the web, and you've got your Fitbits and your Jawbones and your air quality eggs and all these kinds of things, and there are networks like Xively, but also like ThingSpeak. Recently, with my new company, Umbrellium, which I launched back in September with 4 partners, 2 of whom are here today, over there, with a focus basically to think about the role of technology in cities and the role of citizens in cities. We launched something about a month ago called Thingful, which is basically a search engine for the Internet of Things. And the idea now is that we are indexing all of these different networks of data. We're indexing anything public that we can find, and this ranges from weather stations, radiation monitors, energy, et cetera, but also includes networks that are monitoring earthquakes, monitoring icebergs, monitoring sharks, turtles, shipping containers. What we're trying to do is a little bit like what happened in the early days of the web. I don't know whether you remember back to when the web was really just this sort of gray background screen with blue underlined links. But before the search engines came along, you lived in quite a curated world. You probably connected to others on your academic network, or you'd connect to people that you were connected to. But you didn't necessarily have a vision or a visibility onto what was beyond the walls of your own network. And these sort of very early search engines, Alta Vista was another one, later on Google, you didn't necessarily know what was there until you suddenly found these search engines where you could go crawling out to see what was beyond your network. And that's kind of what we're trying to do here, is to say the Internet of Things is now here. I mean, we've got these sort of millions of connected things around the world. But if I want to know if there's an air quality monitor on my street, how would I find that? Unless I know about every single air quality network and I go and check their site, I wouldn't be able to find it. And so Thingful is kind of trying to pull this all together in one place. And so what you can do is you can, for example, you could go and look at your location. So this is sort of zoomed into our location. And there's a bunch of things here that it's found. There's a sound monitor. There is a Hive Sense. What's this? UCL Computer Science Lab. There is, what is this? Office test egg, Twitter stats. So we've got a range of things. Should we go and check out what this Hive sense is? We'll go over here, and we can go into the page and start to find out a little bit more about it, find out all the other stuff that is around that page. Whoops. And we can follow the link through to the data source itself. And if we want to do something with that data, we might do something if we're a developer or what have you. Or if you just want to start to have a discussion about that thing, you can start to discuss that on Twitter. And so what we're trying to do here is enable communities to form around neighborhoods of connected object data. Again, this is about thinking about the citizen trying to make sense of the connected world and putting the power back in their hands to doing something about it. How am I doing for time? Okay, I got another just 3 things, I think, to go through. Reconfigurable house. This is actually jumping back a few years. Was a project I did with Adam Somlai Fisher. You might know him now as the founder of Prezi. But back in that day, I think this was in sort of 2005-ish, we created this PDF called Low-Tech Sensors and Actuators, which is basically a manual for hacking very cheap toys for their sensors and actuators to construct more complex projects and products, if you like. And this cat actually became our universal interface device, because you would clap and it would go meow, meow. And its eyes would light up. And so it became both a kind of sound sensor as well as a touch sensor, and it could convert both of these into a digital output, which was the eyes, as well as a sound output. So the obvious thing, oh, actually, we've got a bit of video here that'll show you exactly what they do. So if you have a bunch of cats, what are you going to do but take them apart, take apart their sensors, and then put them into bricks? And so these bricks became a very low-tech interactive wall, if you like. That was the first step, which was to sort of think about the kit of parts. But what we wanted to do was take this a step further and actually think about, okay, how would we actually use this process on the scale of a house? Because, you know, when we think of the so-called smart home, it's very often sold to us as this sort of seamless box where we don't really know what's going on behind the walls, but we just sort of do something and it responds to us. We wanted to think about a house that was filled with thousands and thousands of sensors and actuators, but where there was no program created by a designer, that the program was explicitly created by the occupants themselves. And more importantly, that they could build that house themselves. So we created a kind of a toolkit and framework, if you like, for creating the reconfigurable house, which was essentially filled with thousands and thousands of these sensors taken from inexpensive toys and gadgets, and then applied a kind of a very simple touchscreen system for connecting them to each other to create responsive environments. And so I think I got some video here. So there's the touchscreen for configuring the house. You could create quite complex response systems. The cats could both respond to touch as well as light up. So this is both a sort of, it responds to kind of movement, but it also has an output in terms of again, the cheeks flashing and the sound output. Now, this led to a kind of interesting kind of conceptual realization for me, which is that the distinction between a sensor and actuator is explicitly determined by the observer, right? Because every single sensor you can think of can also be thought of as an actuator, depending on where it is within the system that you have defined as the observer. So a light sensor, we call it a light sensor, but it only becomes a sensor because you're passing a voltage through it. A cat, for example, is a sensor to sound, but it's outputting digital voltage. And so this was a kind of an important sort of moment for me to start thinking about the way that the designer actually frames for starts to have a way of providing a framework for other people to define what they consider the system, if you see what I mean. And in the reconfigurable house, we were trying to be very lightweight and not actually offer any pre-programmed sequences. But people could take things like the mist lasers and use them to respond to their hands, or they could use them as an output, which was this sort of funky laser through mist. You could plug in your mobile phone so that you could trigger things when you were far away. But you could also wire everything so that it became a disco plugged into your MP3 player, for example. You could create a burglar alarm by taking the monkeys and attaching them to the penguins, which squawk, and et cetera, et cetera. You could sort of create romantic settings by just switching everything off except for the lilies. When they started telling me more about the project, it seemed that there were so many other bits to this environment, which is basically the central park in the town. There were going to be cameras and LEDs in the floor and fountains, and all this sort of technology was being put in without any kind of coherent plan for the way that all this stuff would relate to each other. So what I ended up proposing instead was basically a kind of urban operating system, a way to coordinate and design interactions, but more importantly, one in which other people could start to prescribe, a little bit like Reconfigurable House had done on a small scale, on an urban scale, enable others to start to configure what this environment would do. And so this introduced to me the concept of the granularity of participation. When building these kind of participative systems, how do you build something that has a very wide, that enables people on one hand to have a very coarse participation, because there are some people who don't necessarily want to dive deep into something. On the other hand, there's by going into very fine level of participation, perhaps even opening up the code so that other people can rewrite it, you get this sense of in exactly the same way you have granularity in a photo, that you can sort of think about the granularity of participation. And what I'm trying to do more often these days is to increase that granularity, so that there is a wider range of input points into the project, so that in this project in Bradford, if you're just walking through the space, then it's responding to you, and maybe there's something that you're triggering, and you don't really have to get very deep into participation. If you want to actually get hold of the code and rewrite it, or rewrite some kind of response mechanism at the other end of the spectrum, then that too is possible. And so we had this idea of this interaction engine. There were a whole bunch of inputs and a whole bunch of outputs, and depending on how you configured them, you could have different types of things. For example, if you took the sort of visitor detection and the time of day, in other words, it being night, and you triggered the fountains and the projector and the lighting, then you could create basically a kind of some kind of interactive thing, a little bit like the Primal Source project that I showed, the sort of projected in the mist. If you took the input from your MP3 player and sort of music being contributed, and you could plug that into the fountains, and you could start to create these fountains that would respond to the music that you were playing, et cetera, et cetera. If you know where people are in a particular time of day, and you know where the sun is, then you can generate a rainbow just by knowing that the angle of incidence is 42 degrees, and it's a rainbow that only they see when they do something particular. And in order to do all of this, we created something that we call Linguini, which is basically a kind of software platform that is both for visualizing what goes on there, and that is for controlling it in real time, actually, in the space. Because we're trying to think of a way that you you can design and prototype and simulate and control all within the same environment. And this movie here was actually created, is that Chris back there? Yeah. Yes, Chris back there. I thought I saw him. This was created by Chris. And more importantly, that there's ways for members of the public then to sort of take over components of this and start to re-script it. And so it's up in Bradford. Here's some shots. I hear that we're doing, hopefully doing some more to this. It's been out of action for a few months apparently. So stay tuned for more on that. Oh yeah, we added lasers and stuff. I didn't get to the lasers, but there's a bunch of laser stuff. And finally, Flight Path Toronto. This is a project I did with Natalie Jeremijenko. And for me, this was an attempt to kind of bring together a whole bunch of this thinking about how do you involve people in thinking about not the future. You know, I'm not interested in the kind of science fiction or the kind of design fiction of, oh, we could be here in 10 or 20 years, and let's be ironic about it. But more, where are we now, and what can we actually do now, or what can we do very soon if we put our minds to it, based on the kind of technology that we have right now. I'm really not that interested in speculating. I'm much more interested in building and putting something out there, and actually starting collectively to build that next step. And so Flight Path Toronto was a kind of an attempt at that. And it started from this perspective of the birds inhabiting the Nathan Phillips Square in Toronto, and realizing that birds see the city in a completely different way to us. You know, they see it in 3 dimensions. We sort of see it in 2 dimensions. We walk along flat planes, and then we go up lifts or stairs, and then we come out in 2 dimensions again. So first, the birds are just interesting because they have a completely different way of reading the city. But more importantly, the question of reimagining the city in the context where flight might actually be possible. So, you know, there's, on the one hand, in the US, there's been the introduction of this sports pilot license, which enables you to get a flying license in, I think, only about 25 hours. And so there's a whole class of new planes that are coming about. Of course, there's all this discussion around drones and the relationship the citizens have to those. But more importantly, there's this question about how are we going to get around our cities? How are we actually going to get around these crowded cities? And how are we going to deal with the transportation problem? And what Natalie and I ended up proposing for the square, as a way of sort of provoking people into thinking about getting around the city, was a flight school where you learn about flight. You go through that flight school. You learn about different wings. You learn about different bird wings and how they have different benefits. You then go up a tower and you hitch yourself to a zip line and you fly across the square and across the crowd of people. The idea being that zip lines, you see, you know, zip lines are the things that the military puts across a canyon, are an incredibly fast, cheap, fun, and emissionless form of transportation, goods and people. So rather than putting in more tubes, subways, but, you know, rather than building these stupid Norman Foster, you know, cycle highways, rather than even putting in cable cars, which also need a lot of infrastructure, why not just have zip lines? You could zip line down the road to school, you could zip line to work, you could jump out of your office and be home in about 35 seconds. And, you know, really reimagine what it means to get around the city in a sort of fast and emissionless and fun way. So, yeah, so here's some people flying, practicing flying. Here's some people going to flight school, taking the test. So you actually had to you actually had to go through the test, and you get this thing called the autopilot license that's stamped onto your wrist. I don't think I had a shot there. You go up to the tower, strap on the wings, and then basically jump off. And so this is the idea, you know, again, it's not about science fiction. This is not something that needs a whole bunch of technology to be introduced. It's something we could do right now. And what we're trying to do is create the shared public memory of something that could actually be practically done. Not necessarily the case that we've worked out all the details, but certainly we want to sort of prod people into thinking about a way that they could start to structure transportation. Yeah, even grannies were enjoying the flight. I think I might have some video here. Oh, yes, I forgot to talk about the lasers again. There's somebody just graduating from flight school. So the idea of this laser control tower was that we were trying to flip usually the control tower tells the flyers what to do. And in this case, the lasers were actually generated by people's voices, actually triggering outwards towards the flyers. And so the idea was sort of to flip that response where the control tower is responding to people rather than telling them what to do. So with that, I just want to close with an image from a workshop I did in Pakistan, which was composed of architects and urbanists and engineers from all sorts of backgrounds. And what we did is kind of indescribable. We did something out in the street that involves the sweepers, the shopkeepers, the bus drivers, the members of the public just passing by. I couldn't explain it if I tried. It was a very complex system, but it seemed to work. And the reason we know that it worked was because the way it was designed was that each of these people who's an expert in something knew how what they were doing connected to the person right next to them. And so this had been an experiment in a kind of collaborative design process that was explicitly not about design by consensus, but instead was about design with negotiation with your neighbor. So we made this diagram to explain what was going on afterwards, to describe the relationship between all of these parts. And I want to argue that this is actually what makes a city valuable, you know, making mess, embracing that complexity, not trying to pretend that it doesn't exist, not trying to pretend that we can in some way collapse all of these sort of interesting and rough edges, but actually that the value of everything that we do as designers, but also as citizens, comes from messiness. Thank you. Yeah, I'm happy to answer some questions.
Anybody like to ask one?
No, at the bar.
I have a question because I was just wondering, what are you showing the next time, the project with the lights?
The project with
and also with the sound. I'm interested because I want to be a part of it.
Marley?
Yeah.
We don't have a specific commission at the moment, but we're maybe doing a test in February.
Barcelona?
No, March. Did we say March? Yeah, March. Here in London.
In London?
Yeah, but the location will not be...
Specific place, exactly.
The location is not going to be disclosed to the public because it's a test, but yeah, if you drop us a line, yeah, we'd be happy to have you on. In fact, we're going to need some people to come along so that we can...
And the Batman project?
The which one?
The Batman project? Batman?
Oh! That's a very big and complex project, so we don't actually have specific plans yet, but we have proposed it to a city as a permanent thing, actually as a transportation mechanism. So we'll see how that goes. I would love to do that on a larger scale and permanent.
Yeah, like around the city would be cool.
Exactly. Well, the interesting thing about it is that it doesn't work just for people, but for goods as well. You know, especially for goods that need to be transported regularly and in a kind of local sense. So bread, fresh bread, could be transported at night when fewer people are needing the zip lines. And zip lines in safari parks, for example, can go up to one or two kilometers. And so, you know, there is, it's a pretty easy way to deploy a system where you can start to transport even heavy goods quite a long way.
The Bradford project that you installed recently, how's the uptake of that been in terms of the local community of Bradford engaging with influencing?
That's a really good question. And I don't think it's been very good, actually. And I think that part of that reason is, and this is something we are trying to figure out how to do next time, is that the ownership of it as a kind of, as an artwork, basically, which is the way they saw it, did not comfortably fall in any one particular lap. And it was a bit of a hot potato.
Imposed on that site.
Well, it wasn't so much imposed on it, because it was a completely new development of everything that was going on. So this was a way of sort of unifying that grand scheme. But within the city itself, the city of Bradford, the question of who actually owns that and decides and calls us up when it malfunctions or something like that, you know, that's been a bit, you know, frankly, it's been a bit of a hot potato. So what we're trying to do is actually develop relationships with the local university and some other institutions there to actually take on that stewardship, which I think is, you know, now it makes obvious sense. At the time, we didn't really think about it that way. But in terms of actually building an ongoing a sort of institutional framework that binds it is as important as the actual technological deployment.
Yes, the momentum kind of by word of mouth.
Exactly. This question?
I'm wondering, just do you see your work as sort of a way of combating this sort of heightened individuality that things like Facebook give you, and sort of in a sense to try and restore some kind of human connection with technology rather than just being focused on sort of you having a profile? Is it to you more about sort of reconnecting groups of people together through technology rather than just sort of seeing it as an individual thing?
That's a really interesting question, because I think that I'm actually a little bit conflicted about the whole issue. I don't know exactly where I fall on the privacy debate, for example. You know, on one hand, I'm very private as a person. I'm not on Facebook, you know, I like doing spectacles because I can go and be anonymous in them. But on the other hand, actually, you know, I look at sustainable biological organisms and I realize that they're all kind of sharing stuff with each other, and the idea of this kind of, frankly, it's a sort of Western capitalist idea of the individual, and the sort of ruggedness of that individual doesn't appeal to me either. And so in a sense, what I'm most interested in is to enable people to figure out how they want to connect with other people, or figure out what the best connections are. It's not so much a battle against Facebook as saying, you know, actually there's got to be other ways to connect. And you know, there are potentially richer ways, especially when viewed from the perspective of the city. And you know, again, as I think I said at the beginning, you know, the city is, I love the fact that it's a contradiction. I love the fact that it doesn't make sense, and that it's illogical, and that it supports both privacy and absolute non-privacy. And it doesn't require those things to be logically coherent. And so, if anything, my struggle is against logic, right? It's against the idea that we can make things that are super coherent and seamless, etc., etc. Which is perhaps what Facebook is about.
Back to the Bradford project. Have you thought about, you know, maybe a configurable piece that is related to things that are already emerging in the environment, as opposed to, say, the Bradford one, where you start from scratch and people are kind of confronted with discovering those relationships? Or is that sort of confrontation part of the goal?
So I did a project in New York. This was a temporary piece in Washington Square a few years ago called Project Unspecified, where And I took the notion of being specified or unspecified from Gordon Pask, the cybermatician, who kind of talked about this idea that we could create unspecified systems where the occupants, through their interaction with it, actually start to create the specification of it. And really the only thing that I designed for that was a joint that was a sort of three-way joint for Dexium, the sort of slotted angle metal. That was the only thing I designed. And then everything that was assembled and done by members of the public on the site was what they decided to bring to it, how they decided to assemble it, the plastic bags that they started stitching together with sellotape to infill panels to create a structure, and then occupying it and having sort of different events going on in there, and a sort of a talk, and then somebody, a DJ occupying it. And so that was, in a sense, I think, doing the kind of thing that you're describing, where actually it was almost explicitly defined and designed by what was going on locally. But no, I haven't done that specifically in Bartlett. Feel free to come up and ask any questions.
Thank you very much.